you have high bandwidth communication. Both sides are trying to figure out what needs to be done and where does the boundary exist. So we're talking, we're trying to figure out all these things. But as soon as I commit to it, now we go adversarial. Now all of a sudden, don't want to tell him what's really going on because he's going to get upset. He's over me saying, what's my status? Have you got this thing done that you committed to? The relationship changed completely because they asked for that commitment. And that's one of the things we try to avoid. By just continually feeding this stuff to the client, he doesn't turn around and ask us, well, are you getting this thing done in a month? He's not worried about a month anymore. We're feeding him like a fire hose. So the average programmer is probably going to deploy at least once or twice a day in our system. All right, energy revolution is one of the examples of this. I talked about this last time as well. We bought Uswitch, which is an energy switching company in the UK. Their current system was .NET with SQL Server. It was classic SQL Server. It's got the web servers, the app servers, the SQL servers, multiple machines, load balancers. Microsoft would love this stack. It's absolutely gorgeous. But it's gotten old and needs to be rewritten. They told me at business school, I have a business degree as well, that you should be careful with new technologies. One new technology, okay. Two new technologies, you're putting your project seriously at risk. So armed with that knowledge that you've got to watch out how many new technologies you inject in order to make this change, we decided to write in 4 new languages, 2 new database technologies, including one SQL and one non-SQL, and a whole new way to specify our pages. 8 new technologies. And it worked marvelous. The old system is now turned off. New system is running amazingly well. So much for my business school. By the way, of course, that was the programmers calling it. It says, we're going to write this stuff in Node. We're going, it's part, this is like Clojure to me, Ruby. Oh, this library really just interfaces with C++. We're using C++. Nobody's there to say, no, our official language is Ruby. Or you have to use Ruby without a deviation and get your approval from the architectural review board and all these other things. Nobody was there to ask permission of, so they just did. It turned out was great decisions. Another one from the same project. One of the things that happened was in this .NET system was the calculation for the best energy plan for an individual depends upon the energy history, what zip code they live in, what the postal code is, because there's different plans, different parts. Maybe how big their house is, how many people stay home during the day. There's a lot of factors associated with that. And figuring out the optimal list, and by law, we have to show them the list in the best order for the customer, whether we make any money on that or not. And that calculation was scattered across all the layers, as it should be in a good .NET architecture. Well, we decided that was silly. We wrote it in one Ruby module, about 600 lines of code, and got the algorithm in one place once we finally figured out what it was. So good, we're rewriting this system. This is a good place. Let's move on to something else. What do the programmers do? They rewrote it in Clojure. Because, Clojure, look, it's cool. It's a functional programming language. Look, I got this data input like a function. I want to come out with an array. It kind of looks like a function again. Gee, I think Clojure worked really well. So they tried in Clojure. Came down to about 300 lines of code. And yeah, it was a little cleaner and a little shorter. So what do they do now? Wrote it again. Because now they really understand Clojure. And you're sort of saying, oh my God, why are you doing this? What manager would let them do this? Because I'm trying to rewrite the system, and they do this 3 times. The answer is that's why there's no managers. Now what happened was, we had bad energy news a couple of years ago, that you went through as well. And when bad energy news hits, we make lots of money in Uswitch. We're talking about a 10-fold increase in cycles. And that's why we have all these machines sitting idle waiting for this magic day. Well, it had been about 2 years since the last magic day like this had occurred. And so here's the .NET system. Because we made a few changes to it and never put it under any load, and all of a sudden it's not responding well. The database is running too slow, we're losing transactions, response time is running in minutes to pages. And so we started rerouting some of this calculation stuff over to this Clojure code we'd written. And we kept routing more and more to it. In fact, we wound up pumping all of the code over to the Clojure side to do the calculations for us instead of the .NET side. So we didn't have to use that big database that was falling over. And it took one virtual machine all the way to 30% utilization to handle all that load. In other words, the programmers had made exactly the right choice. They made exactly the right decision by just doing it themselves. Anarchy in action. Another example, click tracking. This is more to home you guys because we basically track a lot of traffic in forward. We get lots and lots and lots of clicks. Lots of clicks. In fact, just in Google ad spend alone, we have now crossed $1 billion of Google ad spend in the last 7 years. We spend a lot of money on Google ads, and we track a lot of stuff. So we have a lot of Ruby servers watching this stuff, keeping track, and help us tune and optimize that system. So it's writing code, it's making us lots of money. So what are programmers going to do? They're going to change it. They decided to introduce Node. And sure enough, it takes fewer servers, utilization drops to a fraction, and even more important, the latency went down. In other words, no manager would let them do this. They did it anyway. Great call. Because this was the time and frame where Google started penalizing you on your ads and whatever if your latency was high. And this kept our ads very, very competitive. Again, didn't need to be done. Programmers said this should be done anyway. We'll see what happens. This is what happened. Now, we do run experiments that don't work. It's okay. So, if you sort of go through the practice that I scratched off, it becomes a little clear what happens here. Because the teams trust each other and they're sitting together, all these techniques called stand-ups, writing big story narratives, and retrospectives are all about communicating among the team. The retrospective is about let's get together, let's figure out what went wrong, let's make suggestions what to do next. Just nobody has permission. Just do it. If you don't like what you're doing, do something different tomorrow. They're talking to each other all the time. The stand-up is something that happens because we're trying to get everybody together so we understand, so the manager understands where everybody stands. These guys are talking to each other all the time. They know exactly where everybody is. So those get scratched off because we're actually communicating a lot. These are all about who do I blame when things go wrong. Making estimates. Oh. Let's just go start another conversation. You think it's going to take 2 days. Good, you say 2 days, okay? Just because you answer that question, I'm going to have another question. Why did it take 2 days? And we'll have another discussion about that. I mean, I'm going to waste more time just because I asked you that question. So my favorite answer, by the way, when people ask questions like this is, how are you going to use this information? Oh, I want to figure out if I can blame you when it's wrong. Then I'm not going to answer the question. You have to be, we're engineers. We're trained to answer questions because that's what we're really good at. You have to repress that. Ask them what they're going to do with this data because I guarantee you there's going to be another question. So be careful with that. Pairing is something that does that when they need to, but when I need help, they pop their head up, they go get help. Again, they're co-located, they respect each other, they value each other's opinion, they seek it actively. These go away for a whole different reason. I have another whole presentation about this called microservice architectures, but we tend to write very, very tiny services now. And again, Node's a very popular language for writing very small services. If I'm writing 100 lines of code and that makes up an entire service, I'm not sure why I have unit test. You can't get 100 lines of code right? And the unit test is all about making sure somebody can change it and not break it. It's 100 lines of code. You can't figure that out and break it by yourself? Excuse me? Maybe you should find a new career. Acceptance test? Well, it gets 100 lines of code. Why would you do such a thing? So a lot of these things fall out because of some architectural choices we made. And again, continuous integration goes away because we're basically doing continuous deployment. I mean, once every 8 minutes. Actually, that was an off week. I've seen it up as low as once every 3.5 minutes before. So we're just doing continuous deployment. So that's why these things get scratched off the list. So why is Anarchy working? It's basically, to some degree, because we have a lot of enablers at forward. First thing you realize, basically, is fear is a bad idea. I mean, fear keeps things from being fun. And a lot of my role in forward was to find the fear things and kill them off. Like people having to make estimates. Because it creates fear. What happens if I don't get it right? We also, frankly, make a lot of money, and we like taking chances. That's a core value of the company. And so taking chances and trying new things, our fundamental business understands about that. We also became very, very developer focused. Even though developers only make up 20% of the company, developers themselves make up sort of the core of the culture. They're sort of the risk takers, the wild, crazy ideas and stuff like that. And they respect each other. The hiring process is anarchy, right? You can't join the ship of pirates unless the pirates want to have you on the ship. So of course they're the guys who decide who joins the company. I may screen some applicants for them to make sure they seem to be qualified, but they make the decision whether they want them or not. And the question is always the same. Do you want this guy sitting at your table? These are very, very motivated guys like yourselves. Who do they want sitting at their table? They want somebody smart. Somebody who can show them some new tricks. Teach them a new language. They want to hire people that are smarter than themselves. Versus the guy who's in a hierarchy organization who cares about his title, who's looking to hire somebody who is stupider than I am, so that you can make me look good, I can be your mentor, and now I become a manager. So from a corporate perspective, you want to hire the stupid people or the smart people. In an anarchy system, you're going to tend to hire the smart ones. Experimentation drives innovation. This is what the programmers came up with as their mantra. It nails it exactly. Experimentation means failure. We're going to try things and they're not going to work. It's an experiment. That's set out right in front. In fact, at any given point in time, probably 2/3 of the developers are experimenting. And most of the experiments will probably not work. The ones that do hit make a lot of money. We did have one year when we had 55 employees where we made 55 million pounds of revenue. £1 million per employee. Risk-taking technology. Let's turn them loose. And finally, one of the things, we brought a venture capitalist in to join our management team to help us understand diversity of various products we could get into. And this is what he said in his first presentation to the overall company. The greatest barrier to success is fear of failure. Entrepreneurs realize fear is the killer of the innovation. And we try to stomp that out. Okay. So, mail online. So I left Forward at the end of 2011, so a little over about a year and a half ago now. And then joined Mail Online. Now, Mail Online, as you know, is the largest newspaper, online newspaper in the world. Let's see if I can talk about that. Yeah, it's the largest newspaper in the world. The company's been founded in 1890, so it's a really old company at some level. The guy in charge of the overall business is Lord Rothermere. He's the 4th Viscount of his generation. So we're talking about a state business with a lord in charge of it, for goodness sakes. So, how do you organize this organization to put anarchy in place? And I took this challenge because I wanted to say what worked in Forward should also work in a very traditional organization. So the first thing is, my job is pretty much the same. My job is to make sure the fear is gone. So the first thing I look at is make sure I kill the fear in the organization.
Sorry, Fred, did you join as a consultant or an employee?
I'm an employee. He knew he wasn't using, I am a good architect. Turns out the CTO is also a really good architect. He didn't hire me to be an architect. But it was the open rec he had and he wanted me. So I was the chief architect. But I wouldn't work any differently whether you call me a consultant or not. The company has a very strong prejudice saying, I'd like to have everybody be an employee. I'm saying, I'm fine, I don't care. So those are the factors that we had in Forward. The only ones we still have in Mail Online is risk. We are a bit of risk-taking business. We know we're an entrepreneurial business at some level because we're trying to be the largest news service online. It's very clear what it means to declare success. Is having the most readers and getting more readers. So that's pretty easy. We've become very developer-focused, and the developers do tend to respect each other. But the rest of those factors that we thought might be very important in order to be successful, they don't really exist. Yes, we're making some money, but we're not making nearly as much money as Forward. Our margins aren't nearly as high. This whole philosophy of trying and failing and stuff like that, not part of the institution at all. In fact, if anything, there's a lot of fear of failure to some degree, because the managing editor can be a complete ogre when he wants to be about this stuff. Lots of fun stories about that. But an amazing visionary. So we only got a few of these factors in the mail online. So how do we implement Agile in this environment, this anarchy in this environment? Well, I've already said all these things, I think. I'll skip that. So here's how the transformation went. Basically, this is what I found. They were, quote, an Agile shop. They're a Scrum, which I consider not to be much Agile, actually. And they were managing at the task level. There was tasks on the wall with people's picture beside them saying they're working on this task today. And the stand-up was run by the Scrum Master, and it was just exactly where on that